Welcome to the 21st century battlefield, where the pace is relentless and the challenges are manifold. And as military operations increasingly rely on data, troops operating in these complex environments face several vulnerabilities due to congested communication networks, which can lead to a dangerous lack of situational awareness. A group of scientists and experts from the NATO STO Research Task Group is working on ensuring our forces access to critical information in order to help them maintain their operational superiority. Enter edge computing, a strategic asset in our arsenal. At the tactical edge, traditional methods of data processing are insufficient, and unfortunately, soldiers on the battlefield cannot always rely on access to a centralized cloud. Edge computing brings the power of computation and analysis directly to the front line. It leverages traditional enterprise cloud technology, but deploys it at the tactical edge. They are called tactical clouds, and they can assist our forces by providing a seamless and interconnected network of tactical clouds for local data processing, storage, and analysis. Here's how it works. NATO forces collect vast amounts of data from various sources, such as sensors, cameras, and drones. This data includes real-time information about enemy movements, civilian presence, infrastructure status, and environmental conditions. Tactical clouds running on edge computing devices close to the soldiers on the battlefield, for instance in military vehicles, process this data locally, i.e. in the tactical edge. These devices serve as mobile hubs, individual tactical clouds equipped with computational power and storage capabilities to handle data processing tasks such as filtering, aggregation, and preliminary analysis. By processing data locally, tactical clouds improve availability of processing resources and minimize processing times. Therefore, they ensure that critical information is available in near real time to soldiers on the ground, without dependence on access to a centralized cloud. Moreover, by federating these tactical clouds, resource availability and adaptability are bolstered, allowing for real-time analysis at the tactical edge. Sophisticated analytics tools within these tactical clouds can extract actionable insights, including pattern recognition and predictive modeling, to support decision-making effectively and dynamically. The high-level architecture for cloud computing at the tactical edge allows NATO allies to mutually use each other's tactical cloud infrastructure, which are interconnected in a federated manner. This setup helps share computing tasks across these different tactical clouds, making the most of processing power without overloading communications. This sharing of computing tasks is adaptive, continuously monitoring both the status of the communications network, the progress of the processing tasks, and the availability of computing resources. Tasks are redistributed when conditions change, such as when a partner's cloud becomes unavailable due to adversary actions, or when bandwidth diminishes as a vehicle with a cloud moves out of range. This adaptive task sharing across the federation of tactical clouds is achieved while each mission partner maintains autonomy over its own tactical clouds. Each partner can define and enforce its own policies and conditions for exposing computing resources to others. This federation of tactical clouds, each operating autonomously, is supported by 4 architectural services deployed on each partner's cloud. The Federated Resource Discovery Service offers information on available and deployed resources and services, such as CPUs, RAM, and storage. It queries both its own and other clouds to collect and aggregate this data. The service provides information about its own cloud's resources and services through an externally accessible interface, known as an Application Programming Interface, or API. The Federated Adaptive Orchestrator Service generates deployment plans for computing tasks across the Federation, utilizing data from the Federated Resource Discovery Service. The Federated Service Deployment Service manages the deployment of computing tasks on its own cloud or other available clouds, following the deployment plans devised by the Federated Adaptive Orchestrator Service. The Trust Resource Management Service collects per-partner cloud security metrics to dynamically compute trust values for all partner clouds in the Federation. These trust values assist other services in decision-making, such as exposing resources and services or allowing specific partners to deploy computing tasks on its cloud. Together, these services enable joint operations of the federated and adaptive cloud infrastructure, ensuring autonomy and security for each mission partner. Implementing these 4 services in each tactical cloud utilizes specialized open-source Kubernetes distributions optimized for low-bandwidth environments. Through rigorous performance assessments, the group has already demonstrated remarkable results. Latency can significantly be reduced and data be enhanced, enabling our forces to potentially gain unprecedented improvements in situational awareness. In addition, the architecture of federated tactical clouds displays remarkable resilience and adaptability, even amidst the chaos of city streets under adversary conditions. For example, in the event of a vehicle with a single tactical cloud being destroyed, data processing can seamlessly be transferred to another partner's cloud on a nearby unit, ensuring continuity of operations with minimal disruption. This is called adaptivity. Let's see it in action. In this simulated real-life demonstration, 4 NATO partners conduct a joint mission in an urban area. Each nation has clouds mounted on vehicles, connected via a disadvantaged tactical network, along with drones and deployed headquarters. Real servers run each nation's cloud. The urban environment is simulated and controlled using the game development software package Unity, which determines the quality of the connections between each cloud and initiates changes to these connections, specifically their bandwidth and availability. For instance, if clouds move too far apart, they lose communication. Unity also displays the services running on each cloud. Each cloud deploys 4 key services: the Federated Resource Discovery Service, the Federated Adaptive Orchestrator Service, the Federated Service Deployment Service, and the Trust Resource Management Service. These services adapt to the status of running services, the conditions of communication links between clouds, and the availability of computing resources. In this scenario, a dismounted soldier with a head-mounted camera records a suspicious car speeding away, uploads the video to a nearby cloud, and informs HQ. HQ decides to perform video analysis, specifically for license plate recognition. The license plate recognition service isn't running yet. HQ creates a workflow, and the orchestrator makes a deployment plan. Since the service requires a GPU and fast access to the data, it's deployed on a partner cloud close to the data and with an available GPU. Unfortunately, before the service can be used, the cloud running it loses connectivity to HQ. The orchestrator creates a new deployment plan based on the updated connectivity situation, and the license plate recognition service is redeployed on an available and connected cloud. Once redeployed, the license plate is identified. Next, HQ needs to find and track the car around the city. This requires a new workflow, involving the deployment of multiple license plate recognition instances to monitor video streams from city cameras or partner nations' video feeds. The analysis resumes, successfully identifying the car driving around the city. Looking ahead, the roadmap includes further optimization of edge computing by means of federated tactical clouds for urban warfare tactics, increased collaboration with civilian authorities to enhance interoperability, and continued development of edge-enabled applications tailored to multi-domain operations. Whether in dense urban environments or remote wilderness, edge computing ensures that our troops remain connected, informed, and ready to respond at a moment's notice. Together, we will leverage the power of this transformative technology to ensure that critical information is available when and where it's needed most, on the battlefield.